Alright, this is a question 7. Sikhuluma ngama acid and bases. Check out the description box for more links for ama questions angaphendulile for this question paper. Lana sizobheka the acid and bases topic. Alright, so this question, don't expect something hectic la. Ne? Do not expect something hectic. It's just a question that I feel like it's good practice as well. Ne? So level 7.1, they are giving us, okay, but they're giving us a sulfuric acid, but it's a strong acid and an example of a diprotic acid. Alright, diprotic acid. Alright, so when preparing for my exam or studying, when you study using my question papers, if you find a question easy, you might skip. Do it. Just write down. Bala pans. It's good for theory, for the theory part. Sometimes uzothola a question with ilula man. You know what? They want a definition. They want mhlambe ukuthi like this question, they are talking about the diprotic acid. What is a diprotic acid? You practicing that uzoyazi off by heart instead of revising before your exam. Ufunda something today, tomorrow uyayikhohlwa. So doing those easy questions or those fair questions, why is it? Just do them. Kuba nalama questions la uthi now ibheke ukuthi you know what, this one ngingayenza ngicimezile, this one with my eyes closed ngingayenza this question. You know what, it's good practice ukuthi no matter how easy the question is, just write down izinto phansi. It also helps you in practicing for ama test wakho nama exams wakho, so that you can write faster during ama exams wakho. Okay, so that's enough rant. As pendulate this question 7.1.1, they want us to define an acid in terms of the Lorentz-Bronsted theory. I mean, I'm not gonna write the definition. I'm not, but I'm gonna tell you. You know it. Namnyayas. An acid is a proton donor, right? It's a proton donor. There's also Arrhenius. Check it out now. There's also the Arrhenius theory. Who was ukuhlukanisa between the two? Ne? Was ukuhlukanisa between the two. But an acid, in terms of the Lorentz-Bronsted theory, it's a proton donor. So 7.1.2, give a reason why sulfuric acid is referred to as a diprotic acid. So in grade 12 we do our pH calculations, ne? So this concept is important in some of the calculations, especially nangabe usebenza ne sulfuric acid. Being a diprotic acid, there is that two factor kwamele we take into consideration when performing our calculations work. Now, to answer this one, what is a diprotic acid? A diprotic acid, it's that acid, a donator or a former not donate but forming two yama protons when it ionizes, right? So a diprotic acid, maybe I can say a diprotic acid ionizes to form 2 H plus ions. 2 H plus ions. Okay, so a nice sulfuric acid is H2SO4. This H2 is an indicator yokuthi you are dealing with a diprotic. You are dealing with a diprotic acid. The di means two, proton, protic acid. Okay. So we now have this. HCO4 can behave either as an acid or base. It can either accept a proton or donate Leo proton yakon. So 7.1.3, they want us to write down one word for the underlined phrase in the above statement. So what do we call this? I also know the ampholite. It's an ampholite. It can behave both as an acid and a base. So this is the ampholite for 7.2. Elena uses a standard solution of sodium hydrogen carbonate to determine the concentration of a sulfuric acid solution. Standard solution, another keyword, especially when it comes to titration. 7.2.1, what is meant by standard solution? What is meant by standard solution? Okay, standard solution, how do I describe this? It's a solution of known concentration. So this helps whenever we perform a titration, as to determine the concentration of the unknown substance, or not unknown substance, ufuna ukuthola the concentration of a particular substance by using a standard solution in a titration. Okay, so write down the balanced equation for the reaction of sulfuric acid with water. Another thing, understand all my keywords now. Diprotic, standard solution, as well as balancing equations. Yeah, balancing equations. I'm sure there is a table I want to compare on a class, or as a list of reactions I want to compare on a class. Metal oxide reacting with the acid, metal reacting with the acid, a base reacting with the acid. The list goes on and on. Now my reactions are on a class, just make sure go to yours as well. Okay, so sulfuric acid nai SO4, it reacts with H2O. Your former ini, it's gonna form what? Write down the balanced equation for the reaction of sulfuric acid with water. Okay, so this is the acid, this is the base. So the acid does what in a reaction? It donates a proton, right? It donates a proton. In fact, this sulfuric acid is diprotic, meaning that you donate a 2 yama proton. So this is what's going to happen. So one water molecule will catch hydrogen A1. Then we want to H3 plus SO4, right? SO4. So thus the H2SO4 komele ilose wonke ama-protons wayo, komele donate ama-protons wayo wonke. Why? It ionizes completely. So labo hydrogen bonke bazo hamba la ku SO4, then siyoba no SO4 minus 2. Okay, SO4 minus 2 lana H3O. Okay, H3O. Alright, so now we have to balance. Let's balance again. So it's now 2 yama hydrogen I4 nakaphelele, right? I4 nakaphelele. Then ngapha I have 3. Ama oxygens wama ingaki I5, nangale ayingaki I5. S1. So now the problem ini ama logange wethu ama hydrogens wethu. So how do we balance? Mostly it's trial and error. ne? It's trial and error. But the three, the three yama hydrogen, it's the only ones like hydronium ions, ne? So yenza life be a little bit easier nyana. Instead of ukuthi ufake izinamba non-stop la. Mina what I normally do, I start with 2. Get it 2 times, I now have what? 6. You have what? 2 times 3 saying na 6 yama hydrogen. You have what? Okay, before ngifaka lo 2, bengino 3, which is an odd number of hydrogens. Ngapha ngina 4, which is an even number of yama hydrogen. So yabona kuba lula ukudila nama even numbers over an odd and even pair, ne? So hence ngifaka lo 2 la. 2 times 3, now sengine even number yani yama hydrogens on the right hand side, but still akabalansanga, still they are not balanced, so nangifaka lo 2 sengina even number nangapha ngina even number, but there's 4 hydrogens on the left, ngapha there's 6. If I put a 2 la, 2 times 2 4 plus 2 6, 2 times 3 6, ama hydrogen abalancile. Let's check ama sulfur wethu. Lo 2 ngimbeka la because if I put u2 la, I'm gonna disturb oxygen further, even sulfur further. I don't know how you solve ama equations, but it's through a trial and errors some of the times. So 4 times 2 plus 2, that's 6. So na 6 pelele, sulfur 1 ama oxygen ayingaka 4 plus 2, that's 6. 2 times 1, that's 2, plus 4, that's 6. Okay, balanced. Kanjalo ke. Kanjalo. So 7.3 sikhuluma nge-titration ke manje. 7.3 titration. In a titration, the learner finds that 20 cubic centimeters of a 0.2 mole per cubic decimeter solution of sodium hydrogen carbonate neutralizes 12 cubic centimeters of sulfuric acid. The balanced equation for this reaction is calculate the concentration of the acid. Let's take out the data. Okay, just take out the data. If you solve a question, then you are about I don't understand anything. Take out the data. Always pull out the data. So we have a concentration here base. Nila 0.2 mole per cubic decimeters. Then it's in a volume of base, which is 20 cubic centimeters, but kumele ngidivide ngobani ngo-1000 so that iba kuma cubic decimeters, ne? So 0.02 cubic decimeters, dm cubic. Let's see, 20 divided by 100, no, 1000, 0.02. Okay, then sizobane concentration of acid, which is equal to unknown. Sibene volume of acid. Oh, okay, I do have a volume of acid 12 cubic centimeters. Divide by 1000, 0.012 cubic decimeters, right? And then between the acid and the base, there's a ratio. Ratio of acid is equal to 1. Ratio of base is equal to 2. So yabokuthi nyaphi na me taking out that data. I hope you understand where I'm going with this. You're inside the titration equation, right? Na over Nb equal to CaVa over CbVb. Na 1 over 2. Concentration of acid, I don't know. Volume of acid, 0.012 divide by concentration of base 0.2, volume of base 0.02. Then we calculate. Remember, we want to make CA subject of the formula, so cross multiply. So thola 0.2 equal to 2 CA 0.012. Divide both sides. So remember, we want CA, so we divide up both sides by 2 times 0.012. So CA is equal to 0.2 divide by 2 0.012. So the answer is gonna be sibale 0.2 multiplied by 0.02 over 2 times 0.012. Answer 0.17 mole per cubic decimeters. So this is the answer here. This is our answer. Then go 7.3.2. Which of the indicators listed below should be used in the titration? Briefly explain your answer. Alright. This sulfuric acid, it's a strong acid. Sodium hydrogen carbonate, it is a base, but question, is it a strong or a weak base? I'm not so sure. Let me just do a quick Google search, because you know. Na, I'm going to wrong this one. HCO3 is it a strong base? Alright. So there's something you need to understand with each choice of our indicators work. Methyl orange is suitable for a certain type of reaction, for my acid and base. Same goes with the bromothymol blue, phenolphthalein as well. So Google search yami sodium bicarbonate or the sodium hydrogen carbonate is not a strong base. It is a weak base. So we have a weak base reacting with a strong acid. So I'm expecting the end point even slightly acidic, because the strong acid will take over. So 7.3.2, methyl orange will be our choice. Methyl orange is gonna be our choice. So methyl orange is our choice. Reason being, a strong acid is reacting with a weak base. It's because of a strong acid reacts with a weak base. So this should be part of our notes work. You should have our properties with methyl orange. When is it used and why? Bromothymol blue, why is it used and why? In what particular reaction is it used in and why? You should know of the stuff. You should have my notes now. Let's talk in the comment section. So for now, guys, I'm saying peace. I hope we enjoyed this recording. I hope it told us some value. If you did, please like, share, or subscribe if you're new to this channel. Thanks. I'll spawn on the next one.